Okay, I think we're live. Hi, everyone. This is Hossein from EJ Academy. Today, I'm hosting Amir.
Hello, my name is Amir from EJ Academy. Glad to be here with you guys today.
So we're going to go over a limit problem from calculus with Amir. Amir is going to solve this problem. So the problem, as you see on the screen, we have two functions, f of x on the left side of the screen in blue, and g of x on the right side of the screen. Both of them are piecewise function, and this problem has three sections. And so Amir, I'm going to need your help to solve, these three sections. So the first part is finding the limit of f of x when x is approaching 3. Floor is yours. You want to go ahead and, start solving that?
Yes, sure. Absolutely. Okay, we have here, let me first activate my pencil. We have here f of x. Okay, let's see. Doesn't work.
I think that's the highlighter you're choosing.
Yeah, that's the highlight, yeah. No problem. Limit of
I'm going to choose the one next to it, the blue one. I think that's the pencil.
Yeah, and I think it doesn't work on the sketch. So limit of f of x, this is f of x, the blue function, when x approaches 3. Okay, 3 is here on the x-axis. As you see, we cannot write on the figure, so no worries. 3 is here. Okay. The limit of a function exists when, limit of f of x, let me write it here. Limit of f of x when x approaches to a from left side is equal to the same limit, the same function when x approaches a from the right side. So, and it equals to whatever number that we have, like b. Here in this figure,
this is the condition for existence of the limit.
Yes, yeah, absolutely. And here we have 3 on the x-axis. When x approaches 3 from the left side, the value of the limit would be 2. And when it approaches from the right side, it's again equals to 2.
Okay. Do you want to write that down maybe for the viewers? It helps to follow.
Unfortunately, I cannot write down on the sketch. I don't know if I can find a way. You see
on the graph?
Yeah, on the graph.
Don't worry about it. Just maybe under the equation that you just wrote, just write down the values.
Yes, absolutely.
From the graph.
So let me write with this color. I like to change colors. Okay, is it the good color?
Yeah, that's fine.
If x approaches to 3 from the left side, the minus is the left side.
Right.
It's equal to 2.
Right.
And as you see, we have a like hollow circle there. It doesn't matter that we have that, but it's a limit problem. So when it approaches from the left side, it's 2.
Right. The hollow circle means that the function doesn't have any value at that point at 3, but that doesn't mean that it doesn't have limit.
Doesn't have limit. Yeah.
Right.
That's a good point. And limit of fx, x approaches to 3 from the right side is again equal to 2, as we can see here.
Right.
So easy peasy. We have the condition, so we can conclude that the limit of fx when x approaches to 3 is equal to 2.
Okay.
So that's the answer for.
This is because both limits from the left and right are equal.
Correct. That's correct.
If they weren't equal, like one was 2, the other one was another number like 3, what would you say in that case?
Yeah, in that case, if we had, for example, as you said, 3, then they are not equal from left and right. Then, according to the limit theorems that we have in calculus, the limit does not exist. So, yeah, that's the catch.
Okay. Yeah, but in this case, maybe you wanted to put it back. Yeah. In this case, it's 2 from both sides, so the limit exists and the value is equal to 2.
And as Hossein mentioned, the value of fx equals 3 does not exist.
Right. Yeah, function at x equal 3 doesn't have any value.
Yeah.
Okay, that's great. Okay, next section, if you scroll up, I can read it from the screen. Okay, so next section of the problem, the second part, you're gonna find the limit of f of x plus g of x when x approaches 3 from the left. The negative means that it is approaching 3 from the left side.
Sure, yeah, good deal. Okay, here we have this guy here. It's a summation of 2 functions based on the theorems that we have in calculus.
Can you write down the theorem?
Yeah, sure.
Probably it's a good reminder for the viewers.
Yeah, sure. Do you want me to delete these guys or just
no, just keep it.
Okay. So this one is for part 1. For part 2. Oh, I think I have to go a little up. Okay. For that theorem, limit of fx plus gx when x approaches to a value like a is equal to the limit of fx plus gx, limit of gx. In other words, the limit can actually go inside the summations.
Right.
So it's going to be limit of fx plus limit of gx.
Right.
And we have to be careful that these 2 guys are the same as this one. So
right.
And vice versa.
They both have to approach the same x value.
Correct.
This is very similar to a distributive property in algebra.
Yeah. Correct. That's correct. Yeah.
Okay.
Interesting. Yeah. When we learn something in mathematics, it can be expanded to other things. That's the beauty of mathematics. So
right.
Okay. Here, let me look at the graph. Limit of f of x when it approaches to 3 from the left side is
you already got it from
2.
The previous part.
Yeah. This guy is here. Let me use this color.
Right. Yeah.
So let me just easily write that. And let me change the color. Limit of fx when x approaches to 3 from the left side is going to be 2, as we obtained above.
Right.
Also, limit of gx. Okay. Gx is the graph on the right side. When it approaches to x3 from the left side, it's going to be 4. I read 4. It's interesting. This function is not continuous at 3. For example, fx is continuous. We shouldn't say continuous, but at least connected.
Right.
because the fx at 3 does not exist, but at least it's connected somehow. But gx at the right side is completely disconnected. In mathematics, we call it discontinuous.
Yeah.
Okay.
So basically what you're saying is that g of x at 3, it has two different limits from the left and right. It's not
correct.
like f of x.
Yes. So from the left side, it's 4.
Right.
Yeah. Let me just write that. Okay. Limit of g of x when x approaches to 3 from the right side, it's 4. And okay, based on the theorem above, we can just easily add them up together.
Okay.
So let me write like this. This is, I call it number 1. I call these two guys number 2. So based on 1 and 2, we can conclude that limit of f of x plus g of x when x approaches to 3 from, I'm sorry, I made a mistake here. Y, it's in here. It should be from the left side. Yeah. They, as I mentioned, these two guys should be the same. Even if the number is the same, like 3 here, they also should be the same from the side, you know, left side both or both right side both.
Right.
So here it should be, let me use this color, it's better. So, okay, from the left side.
Yeah, both has to be from the left side.
Correct. So it's going to be 2 plus 4 is equal to 6.
Awesome. Awesome.
Yeah.
Okay. Let's move on to the last part because we're running out of time.
Correct.
So the third part is finding the limit of a composite function. It's g of f of x when x is approaching 3 from the right side this time.
Yeah.
So how are you going to find that?
Yes. Okay. Let me see. Limit of fg of f of x. Okay. Let me see if this limit exists.
Okay.
Do
we have a theorem in calculus for composite function?
Yes. Yeah, we do.
Yeah, that would be great if you can write it down for the viewers.
Sure. Yeah. Let me see. If that's a theorem that I'm writing, if f is continuous at b and limit of g of x when x approaches to a exists and it is equal to b,
okay,
then limit of f of gx when x approaches to a is equal to f of b.
Right.
In other words, limit of f of gx when x approaches to a, the limit can go inside.
Right.
So limit of gx when x approaches to a. So yeah, I like this one because that's very helpful. So in our problem, we have limit of g of fx when x approaches to 3 from the right side. Let me write down this here.
So based on this theorem, we should go first and find the limit of the function that is inside. Basically, we're going to move from inside to outside.
Yeah, here I'm going to move the limit to the inside.
Right.
So limit of g f of x, x approaches to 3 from the right side. So
Right.
based on this theorem, it's going to be g of limit of f of x when x approaches to 3 from the right side.
Right.
Okay, let me look at the graph. Okay, we have again x equals to 3. When it approaches to 3 from the right side, it's equal to 2 as we had here.
Right. Yeah, we got it in the first part of the problem.
Yeah.
Okay.
So it's 2.
Okay.
So it's going to be, so this guy is 2.
Right.
G of 2. And G should be continuous. According to this theorem, the outside function, you see here, this is the, I call it outer function here. The outer function should be continuous at B. B here is 2. So, and as we can see for the right graph, Gx at 2 is continuous. That's good. That's a good news. So,
actually, I wanted to add something. When you
okay.
go back to f of x, when x is approaching 3 from the right side, f of x is approaching to 2 from the left side, basically. Right? It is approaching 2 from the values less than 2. Right?
Yeah, it's interesting because you know, in the theorem, this guy is B, and B in our case is 2. And this guy is A, and A is not equal to B, and in our case, A is 3 from the right side. So when we first look at the graph, you know, limit of G of f of x at 3, we may say, okay, G of x is not continuous at 3, you know, but it is not the deal, because G of x should be continuous at the value of the limit of the f of x, which is inside the G of x.
Right.
So in our case, our B is 2, because limit of f of x when x approaches to 3 is this guy. So it's 2. And that value of 2 is applied to the G of x, because that's the outer function. And in our case, this guy is B and this guy is A in the theorem. Do you agree?
Yeah, that's correct.
Yeah, and the value is going to be 2, because G of x at 2, based on the graph, is equal to 2.
Okay.
So I think, yeah, that concludes the third problem, and the value of the limit of this function is actually 2.
Okay, sounds good. Thank you, Amir. Thank you so much for helping us and explaining this problem to me and to the viewers. And for the viewers, that is all for today. Thanks for watching this video, and till next video, cheers.
Bye.
Bye.